What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.4, which is compositions of transformations. So to be able to determine the image of a figure after a composition transformation, and then also describe transformations that are producing the same image as a reflection in two lines. We got some vocabulary terms to start off with, and then we'll try 4 examples after that. So the first thing we want to know is, well, what is a composition transformation? And we're going to go and type that here. That is when a transformation is applied to a figure and then another transformation is applied to its image. So almost like a double transformation. The other transformation we're specifically going to talk about today is a glide reflection, and that is when we have a composition of a translation followed by a reflection in a line parallel to the translation vector. Okay, so I'm going to draw an example of a composition of transformations, which is also going to show a glide reflection. So say, for instance, we have triangle ABC, and we're going to translate that figure maybe 4 to the left. So A prime, B prime, and then C prime, okay? Then we're going to show a reflection, maybe from, like here would be like the x-axis, and we would reflect over that x-axis so that we would have A double prime, B double prime, and C double prime. So just make sure you're noting the primes and the double primes, okay? So we're going to see some of those today. Let's go ahead and get started with example 1. So the first example says triangle PQR has vertices of 1, 1, 2, 5, and 4, 2. Determine the coordinates of the vertices of the image after the translation along -4, 0, and a reflection on the x-axis. So -4, 0 means just we're moving left 4 units and then stopping, and then we'll try our reflection on the x-axis. Let's go ahead and start with point P. So these should have shown up as arrows. That was my fault with formatting. So point P is at 1, 1. To go 4 units to the left is 1, 2, 3, 4. So P prime is ending up at 3, -3, 1. Q is going 1, 2, 3, 4. So that is -2, 5. And then R, 1, 2, 3, 4 to the left, that'll be 0, 2. So I'm going to go and label those P prime, Q prime, and R prime. Then we're going to show the reflection across the x-axis. Remember, your x-axis is here, working from left to right. So when we do that, we're going to have P drop down 1 on the other side. So P double prime is at -3, -1. Q prime, we are at 5 units from the x-axis, so we'll go 5 units on the other side. Q double prime is now -2, -5. And then R prime is 0, or 2 units up from the x-axis, so we'll go 2 units on the other side. That labeled now is going to be 0, -2 for R prime. And then we'll connect our points so we can see our translation and our reflection. Next up, we're going to take a look at example 2. So if you'd like to, go ahead and try example 2 on your own. And then when you have a good stopping point and you're ready to check your work, let's go ahead and do that. So go ahead and take a moment here to pause, and then we'll check back in to see what we've learned. All right, just move my computer around. Here we go. So triangle ABC has already been graphed for us. So what we're going to look at is first a rotation of 180 degrees. Remember, 180 degree rotation is just making your x's and your y's their opposites. So that'd be -x, -y. So -6, -2 would change to +6, +2. -5, -5 would change to +5, +5. And then -2, -1 would change to +2, +1. So let's go ahead and plot those new points. So 6, 2 is A prime, 5, 5, B prime, and 2, 1 C prime. So here's my first transformation. And then I am translating along -2, 4. So that is left 2 and up 4. So let's start with point A. Left 2, 1, 2, up 1, 2, 3, 4. A prime is now going to end up at 4, 6. A double prime. B double prime, left 2, 1, 2, up 1, 2, 3, 4. This one's going to go off the coordinate plane just a little bit. That'll be 3, 9 for those points. And then C double prime, left 2, 1, 2, up 1, 2, 3, 4. We're looking at 0, 5 for C double prime. And then we would just connect our points, and there's our triangle after a rotation and a translation. Example 3 is talking about, are the triangles ABC and DEF congruent? If so, what composition of transformations maps ABC to DEF? So first thing I look at is congruency. So I'm supposed to figure out, is AB going to match DE? And first I would say, okay, AB is 2 units and DE is also 2 units. Okay, cool. Then does BC match EF? BC is 1, 2, 3, 4 units, and EF is also 1, 2, 3, 4. And then from there, 2 squared plus 4 squared is going to create the same rectangle, or so the same right triangle. So I can say that yes, they are congruent. And because they are congruent, then I can decide what type of transformation did it go through. So one thing I might have thought of was reflecting over the y-axis first. So C can be 2 points away from the y-axis. So I'm going to say C prime could be 2 points away from the y-axis here. Same thing with B. And then A is just 2 steps away from B. So there's my A prime. Okay. Once I did that, then I thought, so I'm going to go ahead and write down reflect over y-axis. But it's still not oriented the same way that I want it, so maybe I would think about step 2, reflect over the x-axis, which would mean B double prime would end up here, A double prime would end up here, and C double prime, 1, 2, 3, 4, 5, 1, 2, 3, 4, would end up down here. And then I'm pretty much very close to getting ABC mapping onto DEF. All I have to do is now translate it 1, 2, 3 units to the right. So I'm going to write translate 3, 0 with my vectors. Okay. Yes, there are other ways that you could have done this. Maybe you did a reflection over the x-axis and then a reflection over the y-axis. Both of those would work. So just thinking about how those connect. In example 4, are the segments XY and PQ congruent? If so, describe the transformations that map XY to PQ. So that means X has to match with P and Y has to match with Q. The first thing I would want to do is make sure that they are congruent. So you would use the distance formula here. X is at 1, -3, and Y is at 4, -1. So using the distance formula, I just did -1 minus 3 squared plus 4 minus 1 squared. This will be -4 squared and 3 squared, or let's see, 16, -1, -1 minus -3 would be -1 plus 3. So that'd be 2 squared, so that'd be 4, excuse me, and then 3 squared is 9. So I'm going to get the square root of 13 as the distance for xy, and then for distance PQ, P is at 0.71 and Q is at what do we see, 54. So that distance I would find 4 minus 1, square it, and 5 minus 7, square that, 3 squared, -2 squared, still going to give me a 9 and a 4. So their distances are the same, so yes, congruent. Now I just got to figure out, how does XY map to PQ? What I'm thinking is, here I am in quadrant 4, and I want to be up in quadrant 1. So I'm thinking maybe a rotation first of 90 degrees counterclockwise. Remember the rotation of 90 degrees counterclockwise. I'm going to write the algebraic rule right here. Pushes our y to the front and makes y negative, where x stays the same. So that would mean x right now is at 1, negative 3. X prime would then excuse me, end up being 3, positive 1. So here would be x prime. And then y prime, right now it's at 4, negative 1. So push my y to the front, give it an opposite 1, comma 4. And there we can see that they are parallel. So the only thing left to do would be to scooch it over to the right with a translation of 1, 2, 3, 4. So we're going to say translate 4, comma 0. Okay? So again, that could have been maybe done in a different order. I just thought rotation of 90 degrees counterclockwise was best to get it up in quadrant 1 and then translating it 4 units to the right. That'll conclude our notes on 4.4. Thanks so much for tuning in for compositions of transformations. Tune in next time. We talk a little bit about tessellations. Have a great day.